Isaac, laureate of the Da Vinci Institute.
Today we will be talking about arithmetic. Arithmetic comes from the four basic operations: addition, subtraction, multiplication, and division. And in fact, as you may not know, arithmetic actually originates from our ancestors all the way back in Africa. In the Belgian Republic of the Congo in 1950, now the Democratic Republic of the Congo, this bone, the Asongo bone, was found. Likely the bone of a larger mammal, like a large cat or a baboon. This bone is 10 centimeters long and has several notches inside it. These notches were most definitely not used for decorative purposes, but they are very organized, so they were most likely used as measurement tools. There was evidence that our ancient ancestors from Africa, in fact, even knew about prime numbers, multiplication, division, and had systems of base 10 and 12. Now, when people say arithmetic, they usually refer to basic math. So, basic math refers to the four operations. So, what are these four operations? Well, number one is addition. Now, addition is when you add two quantities. Quantities, they're numbers. So let's say let's see how many buttons I have on this calculator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 47. So now, that amount of numbers, that's a quantity. So that's an amount of something. So if I say had 49 apples, so let's say I had 49 apples, or let's say I had actually something smaller, like 3 apples. So now, let's say that I take my 3 apples and add them to 8 apples. Now, since I've added 3 to 8 apples, how many apples will I get in total? Well, what is adding? It's just putting numbers together. So, the addition sign is used to represent adding. So 3 plus 8 is really just a way to say combine 3 with 8. And that should be easy. You just take 3, you take 8, put them next to each other, boom. How many do you have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, what do you write here? You have 11. So, 3 combined with 4, the newer version, added to 8 is 11. But what if we wanted something even shorter than that? Well, let's take that added to and let's convert that into a new sign, plus sign. Let's take that if and let's make it an equal sign. Now, in reality, in the olden days, before the equal sign was invented, people used to say is equal to, until one guy in 1557 got tired of writing it repeatedly, and so decided to write 2 parallel lines, which would represent equality. It was originally 3 parallel, but they changed it to 2. So now, 3 plus 8 is equal to 11. That is addition, combining numbers. Combining numbers. Let's take this we have over here, scale it down. How would I scale this down? So let's put it right over here, and that's it. All right. So now, what about subtraction? Now, what is subtraction? Well, it's the opposite of addition. It's taking away one number from another. Away one number from the other. So, if we had, say, 9 boxes, and then somebody breaks into your home and steals 2 of them. So I'll illustrate that by drawing a little bag which he carries 2 of his boxes that he stole. So now, how many boxes are left now that he stole 2 of them? Let's see. Actually, his bag leaks, but he fixes it. So now, how many are left? How many boxes do you have left once this dirty thief takes 2 away from you and you had 9 originally? Well, you originally had 9, the thief took 2 away, and so now let's count how many we have. 1, 2, 3, 4, 5, 6, 7. That means 9 minus 2 is 7. So 9 with 2 taken away from it is 7. Or 9 taken away, 9 with 2 taken away from it is 7. Or 9 when you take 2 away from it is 7. So taking away one number from the other. Let's put our demonstration, size it down. Perfecto. Alright. So now we have multiplication. Multiplication also has some symbols that are used later in mathematics, like the asterisk or the ultimate dot. There's also division. So let's see multiplication first. And, well, multiplication is a bit complicated to explain, but essentially it's just repeated addition. And division is splitting things into equal groups. So let's see multiplication, repeated addition. So now let's say you have 5 times 4. What does that mean? Well, let's say you have 5. Now, multiplying it by 4 means that now you want to have 4 copies of 5. What the? So multiplying it by 4, what? Never mind. So let's say you have 5 and you want to make 4 clones of your 5. That means that you have 5 times 4. So now, here are your 4 clones of 5. Now, how many rows of clones are there? 4. How many were there originally? And now how many columns are there? 5. So, that means that you have 5 times 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 5 times 4 is 20. So it's repeated addition, or cloning groups. specific amount of time. So now let's size down our demonstration, size it down a little bit more, and perfect. Alright, so finally we have division, splitting things into equal groups. So if we take, say, a group of 40, that's just an arbitrary number I picked. So let's see how fast I can draw 40. Only 1/5 of the way there. Halfway there. 24, 28, 32, 36, and this should be 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 4. Alright, that's 40 circles. And so now, what I'm going to do is I'm going to divide this by 8. What does that mean? Well, I have to make 8 equal groups out of it. So does anybody see how we can make 8 equal groups? Well, if you don't, I'll show you. Let's take one group. Alright, we have one group. Let's take another group. Group. Bam, we have another group. Let's take a third group. Group. Wow, this is working really well for us, isn't it? Let's take a fourth group, and bam, we're halfway done. A fifth group. Let's size these down so it's gonna be a bit easier to fit. Let's bring them a bit closer to each other. Looks like a puzzle, doesn't it? And so now, let's try going from the other way around in really weird directions. So this, size it down. There we go. Now let's do this. Size it down. Oh goodness. Now we take these. Size it down. There we go. And then now we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 left. So we take 5. There we go. And we have 5 remaining. So bam, how many are there in each group? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now, how many are there in each group? There are 5 in each group. And thus we write 40 divided by 8 is 5. Essentially, take this number, divide it into this amount of equal groups, count the amount of circles or the amount of whatever you have in one group, and that will be your answer. So now, let's size it down. Let's see. How can we bring this in here? Yeah, that should be good. Alright, so now there is one last thing. There are a few things I would like to mention before we go. So now, number 1 is the equal sign. Probably see it operating in the background the whole time. But this equal sign is supremely important. 2 plus 5 is equal to 7, for example. You spot it? There it is. It says that it's making a comparison, really. So this equal sign is saying both sides are the same. when you have a balancing scale and you put two equal objects on it, and you see they're the same. So that gives you information. So 2 and 5 together and 7, they're the same. But say we had 2 plus 52, then the scales would probably tip over in the favor of this. So now, let's see. This is the equal sign. Basically says, if both sides of me, the things on both sides of me, they're equal. And do not fret if you see something like this. That basically just means that all three of them are equal. Because this and this are equal, this and this are equal, and since these two are equal and these two are equal, then this must be equal as well. And the final thing I would like to show you is the commutative property. It basically says you have addition, subtraction, multiplication, and division. Some of them have the commutative property. Some of them don't. The commutative property basically says, alright, you have a statement over here, but is it true when we switch the orders of the thing used to make it? So 2 times 5, what about 5 times 2? Well, that's still 10. However, let's say we take 9 minus 4. Now that's 5. But if we switch it around, do we get 5 back? No, we do not. So, this is an example. This is not commutative. And this is commutative. So, that is all we have for today. Before we do that, let's just bring this huge, oh my god. Let's bring this gargantuan guy up to the surface just so we can see how far we've come. That is Arithmetic. Thank you everybody for watching.